Hey, so here's the questions that we're doing in class today. Now, when I go over them, if you actually see a wee thing that says N5, that means if you're doing National 5, then this is the type of questions you could get asked as well, right? So, first question, black and white picture, and they're just asking you just to calculate the storage requirements. So, they've given you dimensions in pixels, which makes things a load easier. So, you could even just write it's 600 by 400 pixels. So all we need to do is find out the number of pixels, and the key is the fact it's just black and white, so that just means 1 pixel equal 1 bit. So if we calculate the number of pixels, that's going to be equal to the number of bits. So what we do is we just say that equals 600 times 400, and you're essentially just saying times 1. Okay, so obviously you don't need to put that, but just to make the point that 1 pixel equals 1 bit. Now this will give you the answer in bits. So, and then you want to get it to a good unit size, right? So if we turn this on, move that up slightly, what we've got is we go 600 times 400. I think it's harder to see this one compared to the last calculator, and then you press equal. And that is it in bits. Okay, so that's 240,000. Now, we want to get it from bits to bytes because that number's far too big. So we divide by 8, and that's a number in bytes, so that's 30,000 bytes. Now that's still too big, so to get it from bytes to kilobytes, we then divide by 1024, and that gives you 29, we'll just round it up to 29.3 kilobytes. So that equals 29.3 kilobytes. So as soon as you find out the number of pixels, you just times it by the colour depth. Black and white just means the colour depth is 1, okay, because you just need 1 pixel. 0 is white, 1 is black. And then after that, you want to work on it so it's a good size unit. Next question, and again, this could be something for National 5 candidates. Again, you're wanting to say that's 1,000. And that's 500. Okay, so again, you just multiply them together to find essentially it's the area, but it's the number of pixels, and times each pixel by the colour depth. Now it's saying here the colour depth is 4. So for each picture you have, the computer's actually using 4 bits to save it. So this is 1,000 times 500. Okay, so that times that, but for each pixel times 4. So we then put this in a calculator. So 1,000 times 500 times 4, and that is 2,000,000 bits. So that's 2 million bits. Then get it into bytes, so divide by 8. That's 250,000 bytes. So that's divide by 8, and then we go divide by 1,024. Probably run out of space. Divide by 1024. And this equals 244.1 kilobytes. Okay, so again, it's the same format. You get the dimensions in pixels, and then you multiply them together and just times it by the colour depth. Now, this is using 16 bits. Okay, so 16 bits, and it's 600 by 600 by 16 bits. So yeah, essentially, so that should say pixels. So again, that's 600 times 600, and then times 16. And that will give you it in bits. So again, so you'll start getting the hang of this. Times 600 times 16 5760000 bits. Again, divide by 8 to get into bytes. 7200000 bytes. Divide by 1024 to get to kilobytes. That's 703.1 kilobytes. Right, so that's the first page. So it's just all about calculating the size and then timesing it by the color depth, or calculating the number of pixels, should I say. Right. So again, this one here, they don't give you the actual colour depth, but they tell you it's true colour. So hopefully by now you remember the word true colour means the colour depth is 24 bits. Okay, so that'll be a JPEG. So again, it's 1800 pixels, and there's no harm in actually writing the dimensions on the actual picture. And you now know it's 1800 times 1200, and times that by 24. So that equals 1800 times 1200 times 24. That's 5184000 bits. A good chance this might go into megabytes. Divide by 8. 6480000 bytes. And divide by 1024. 6328.1, that's kilobytes, and there's still room to get into megabytes. So again, remember, just divide by 1024, and that is 6.2 megabytes for that picture, which is quite a reasonable size. Now, there's a wee problem with this one. This one's problem is the fact that they've not actually given you the colour depth, so we'll make the colour depth there 16 bits. So all we're doing there is 4000 times 3000 times 16. That's a number that is pretty large. Okay, and that's in bits, and then it becomes an exercise of just converting units. So divide by 8. Divide by 1024. Kilobytes. Divide by 1024 again. And that's 22.9 megabytes. Okay, so these are the sizes of pictures if you think about the actual number of pixels and the colour depth. Okay. Now, question 6, they're asking you bitmap with resolution of here, state of storage required on the hard disk. So resolution 1024 times 768, and it's 8-bit. So if you're doing National 5, you only go up to 8-bit at the most. Okay. So again, we've even done the first bit of the calculation for you. So 1024 times 768, and then times 8, and we're nearly done. That equals 626688, that's in bits, and then you just work your way through the units. Divide by 8 equals 76336, and that's bytes. And then divide by 1024 equals 76.5, and that's kilobytes. And your last one. So we've got That way. Right, we've got another picture, we've got the resolution, so that should be in pixels, so in case you thought it was inches, and that's 16-bit, and then it's how many of these pictures can get stored onto a 2 GB card. So we find out the size of the picture, and then we can suss out how many can actually fit into that card. So if we then just do this wee calculation, bits will start coming second nature. Divide by 8, 1, 2, 0, 0, 1, 2, and divide by 1024. So it's 1171. And we'll just round that to 9, so that's 9 kilobytes. And then divide by 1024 again to get it into megabytes. So that's 1.14 megabytes. Now we've got 2 GB cards. Now if you want to get 2 GB, the number of megabytes is 2 times 1024. Okay, so that will be 2048. So we want to find how many of these pictures go into this card. So all we do there is 2048 divided by 1.14. Remember, if it's a number with a decimal point, you just round down because you don't want a 0.8 of a picture. So 2048 divided by 1.14, and that is 1796 pics. Okay, so that was the answer there. So we just round it down. Okay, so you won't have a 0.49 of a picture. And that's answers to the work that you did today.